This is Jaguaria Eva in Paraná state in the southern part of Brazil. Here lies Placas do Paraná's new MDF plant.
Placas do Paraná is one Brazilian company, depend the French group Louis Dreyfus.
The company is recognized as a producer of high-quality particle board. Why have they moved into MDF?
Placas do Paraná is leader in the particle board in Brazil. Illogical, the second step in the different products would be MDF.
This line, from debarking drum to packing line, is a complete delivery from Metso panel board.
Our philosophy is to choose only one responsible against us.
All process machinery is engineered by Metso panel board. The only exclusion was the sander, which was supplied by Steinemann, but with an interface managed from Metso. The factory is rated at a capacity of 225,000 cubic meters of MDF per year. The main equipment arrived to site at the end of March 2001. The first board was produced 6 months later. A 40 megawatt energy plant delivered by Metso panel board provides heat energy for the mill. The plant has 3 sources of fuel: bark from the debarking, process waste and purchased wood waste. Special burners capable of providing 19 gigacalories per hour handle the sander dust. A 54 cubic meter grate floor provides the energy from bark and other waste wood material. The plant adjusts automatically to the load balance required in the MDF mill. Hot gases are supplied to the 2-stage dryer and for heating the thermal oil for the press. Steam is generated to feed the defibrator system and wax melt. The mill is self-sufficient regarding systems to generate heat energy. The raw material is Pinus tadea from the company's own plantations. It's delivered to the plant at a rate of 50 trucks daily. A knuckle boom loader purchased locally by Placas feeds logs to the gentle feed log handling system. This is followed by a single easy-tire debarking drum. The logs are discharged into a Kamura chipper. The chips are transported on the 130-meter-long conveyor into the chip silo. The covered storage prevents wind blow of the chips and allows 10,000 cubic meters of chips to be stored over the single reclaimer with fully automatic operation of the chip reclaim. The wet wood waste system, with a similar level of automation, feeds the Metso energy plant. A discharge screw feeds chips from the silo to another conveyor that feeds a chip screen. Accepts are fed to the chip washer, featuring a scrap separator. The clean chips are pumped to the defibrator building and drained into the surge bin above the preheater. An M60 defibrator provides a capacity of 22.5 tons of fiber per hour. The glue kitchen features 3 resin tanks with 4 pumps for blowline blending of the various components. Steam from the energy plant is used for wax melting and to maintain temperature in the day storage tank. The kitchen also features a pressurized flushing system to clean the resin lines. The fiber preparation is followed by a 2-stage flue gas heated dryer with RAS, or return air system, heat recovery and fiber conditioning. A discharge conveyor feeds the fiber to a Z sifter, which is equipped with fiber conditioning. The supply air and air from the blowbox fan is heated, and steam is injected into the recirculation air to maintain a fixed relative humidity. Every effort has been made to reduce the effect of the outside climate on the plant, to ensure repeatable drying, conditioning and forming conditions. Fiber from the Z sifter is fed to the dosing bin above the pendulum chute of the uniformer active former. The movements of the chute are accomplished by a servo motor. The length of the stroke, as well as the speed for 4 different sectors, is controllable, which allows the operator to trim the filling rate across the dosing bin at the time of the startup of the system. The dosing bin acts as a buffer for any change in feed rate from the previous link in the chain. A rakeback conveyor on top is used to keep the fiber in the bin at a constant height as it reaches the doffing rolls. The discharge rate is controlled by a variable speed drive unit, which operates the bottom feed belt. The former is adjustable to produce a mat width for the press from 7 to 9 feet, that's 2.15 to 2.8 meters. The forming head with its forming rollers works in the mat as it's being formed from the bottom up. The angle of the forming roller bed is automatically adjusted to allow the highest roller to even out the mat surface as it's being formed. The roller bed is automatically tilted in such a way that the height of the first, lowest roller is set in a selected ratio to the height of the last roller. The angle at which the bed will work is thereby a function of the bulk density of the fiber and the desired mat weight selected by the operator. When rotating the forming rollers, the fiber is thrown back and forth sideways, and as a result of this, an even fiber distribution